Good afternoon, everyone. My name is Jonathan Hodges, as Ben says. Thanks very much for the opportunity to come and talk to you all today. I realise that there's probably quite a wide range of people in the room, people who know exactly what Wave Energy Scotland is, people who are already part of the Wave Energy Scotland programme, people who work for Wave Energy Scotland, and perhaps people who work on different types of energy in the IES area. So I'll try and sort of pitch this appropriately so that it can be interesting to everyone. So I'm part of a small team of the engineering side of Wave Energy Scotland, based on the King's Buildings campus, and we're about to move up to the energy at the Edinburgh Technology Transfer Centre upstairs. So it's nice to have the opportunity to tell you what we're here for and what we're doing. So what I'm going to talk to you about, I probably won't take a full 40 minutes, but what I want to talk to you about is the context of Wave Energy Scotland, what it is, what are the objectives of Wave Energy Scotland, and what the programme looks like. So what are the calls we're running, who's in the programme, what sort of technology is being developed in Wave Energy Scotland programme, how are we managing those calls, and what's the sort of process of Wave Energy Scotland, and how does it look. And then I'm going to go a bit onto international collaboration activity and why it's important to what we're trying to achieve. And one of the aspects of that is measuring success and sharing the information that comes out of the programme. So it's going to be a tour of what WES is, why we're doing it, and what's happening in the local area. So first of all, a bit of context. Why Wave Energy Scotland? So Scotland has long been a hub of activity and development of technology in the wave energy sector, and there's a huge amount of learning that's happened over the last few decades. Wave Energy Scotland came about in the context of an industry that had had a lot of public funding but not managed to achieve the development of commercially successful, commercially viable wave energy technologies. So at a government summit in early 2014, there were some conclusions came out that proving the technology had to be the priority rather than all of some of the other aspects of research and development that are important, but without the technology we're not going to get towards a successful wave energy industry. So the approach to do that was decided that structured collaborative approach was not just a nice to do, but it was absolutely essential, and that we needed to bring what they called some cold industrial logic into the programme, into the innovative process. So we need the line of sight to market, and there was a lot of support mechanisms aimed at developing a market for wave energy. But the line of sight of technology was much more important than that. So Wave Energy Scotland was set up in November 2014, so it's nearly 2 years old now. And it was kind of a fresh approach to the funding of technology development in the wave energy sector. A much more methodical, stage-gated approach to increasing the scale and the confidence in the technology slowly to the point where we can have a confident private sector and get investment back into the sector. So that was the sort of government thinking and the strategic thinking that came about, that brought about Wave Energy Scotland. So what is Wave Energy Scotland trying to achieve? I've got some words at the beginning of this presentation to sort of tell you what we're doing and why we're doing it, and then we're going to go on to some nice pictures of what the technologies are. But effectively, Wave Energy Scotland's objectives are to retain intellectual property and know-how in Scotland for future benefit. I said that there's loads of activity that's happened in Scotland over decades now, and one of our objectives is to make sure that that is saved and shared across the sector for the benefit. So, enable Scotland's indigenous technologies to reach commercial readiness. And I'm going to show you exactly what the programme looks like that's intending to do that. The intention of that programme is to get to the point where the public sector support can exit, with the preference going to private sector, who have at that point increased their confidence in the sector and the technology being developed by it, so that it can move towards a commercially viable industry. And alongside the first point there, it's all about ensuring that the learning that's been done in Scotland and elsewhere is retained for the benefit of the wave energy industry. Some of the bits I'll talk about later, which is more around the sharing of information that Wave Energy Scotland is carrying out. It's important that that's carried out so that we can avoid duplication of funding, because public funding needs to be used appropriately for best value for money for the taxpayer. So we need to make sure that we avoid duplication in funding, ensure value for money, and overall promote the confidence in the private sector. So that's what WES is trying to achieve. That's the objectives of the programme. So what is Wave Energy Scotland? Basically, it's a research, development and innovation programme. And I've got quite a bold quote up here from the Managing Director with the intention that by 2020 there will be wave energy devices that have come through our programme being deployed at the European Marine Energy Centre, and they'll have the economics, reliability, costs and performance absolutely right. So that's what Wave Energy Scotland is trying to achieve, and by doing that, by demonstrating those technologies at EMEC, the European Marine Energy Centre, we'll get to the point where private investors can see that, see those prototype devices being deployed. They can see that it's been through a really sensible, structured, methodical development approach, and they can build confidence that that's something that they want to invest in, and that investment is what's required to take this from the nascent industry that still is into a commercially viable sector. So that's what we're trying to achieve. So just a quick list here of what is in the WES programme, and I'll go into more detail of some of these things. Behind the actual approach to Wave Energy Scotland is a thing called pre-commercial procurement, and that is a method of funding which allows us to provide up to 100% funding for research and development projects, and that's quite different to some of the other public funding mechanisms that have been used before, which require investment from the private sector. As that private sector investment is not forthcoming at the moment, pre-commercial procurement is a very good way to pull forward the technology development. So, just a list of the types of projects that are happening within Wave Energy Scotland. Know-how and project secure, those are projects intending to secure existing IP and know-how that has already been created over decades within Scotland and make that available to the sector. And then within the actual innovation programme, we're developing power take-off systems, novel wave energy converters, an aquaculture project. We've got a lot of research activity going on. We're currently procuring projects in structural materials, which is the next call following on from novel wave energy converters. In the future, we'll be looking at activity developing control systems for wave energy converters, and we've also funded a couple of ID Core students who are based here, Anthony and Enrico, who you all know. So we're moving on to testing of the technologies that are being developed through the programme, and we're also involved in activities like standardisation, which is something that's really important in a growing sector, that we have standardisation that allows people to work to a common set of guidelines and avoid variation in the approaches they're taking. So that's a quick summary of what is in the programme. So what does the programme look like? In contrast to some of the other funding mechanisms that have gone in the past, there's been a history of large amounts of public funding going to develop and deploy very large devices, very large wave energy converters in the sea at EMEC, perhaps without going through such a structured process that the Wave Energy Scotland's going through. So instead of those very large devices famously being deployed in the sea, we're taking perhaps what you call a more nuts and bolts approach. Going in, developing the subsystems individually that are absolutely necessary for a working wave energy converter. So things like power takeoff mechanisms, as I said just now, things like structural materials, what materials are the best available for reducing the cost of wave energy converters. In the future, control systems, and alongside that, a development programme for actual wave energy converter concepts. The idea being that there's a huge amount of existing sector knowledge over here. Once you've developed the subsystems and once you've developed wave energy converters, you're getting to the point down here where you've got all of the ingredients that you need to build a successful wave energy product. And that's the whole idea of the programme. Develop and remove risk from the subsystems, develop the concepts, and come to the point where you're able to integrate all of those projects, all those products together, and you can achieve the capabilities and the sort of measures that a successful device needs. It needs to have the right performance, it needs to have the right cost of energy, the right costs, and it needs to be reliable. Once you've got that proof of concept, then you're moving towards what you need for a commercial project, a commercial product. Things like performance, reliability, guarantee, all those things that a commercial world needs. and all the things that a private investor needs if he's going to see wave energy technology as something he wants to invest in. So that's the structure of the Wave Energy Scotland programme, and what I'm going to do now is talk to you about these calls, power takeoff, materials, control systems in the future, and wave energy concepts, and just give you a little bit more detail of who's in those programmes, what companies are involved, what sort of technologies they're developing, how do they fit together in the future. So this complicated diagram is just a very quick illustration of what types of technologies we've got in the programme. So top half, power takeoff systems, and the bottom half, novel wave energy converter concepts. So you'll see 5 bubbles on the top, which illustrate the types of power takeoff devices that are being currently developed in Wave Energy Scotland. So dielectric elastomeric generators being developed, direct drive electrical power takeoff mechanisms, gearbox-based power takeoff mechanisms, and then you've got hydraulics and also polymer springs. So that shows what a great range of different technologies are being developed. Couple that to the types of wave energy converters that exist in the world and are being developed in the programme. You see, I'm sure many of you have seen these aquarette illustrations of the different types of technologies that are possible within wave energy conversion. Things like attenuators, point absorbers, oscillating wave surge devices, oscillating water columns. You can see that by these orange dots, which the 3-letter codes will mean nothing to you, but they are companies, that just sort of illustrates that we've got technologies developed across the range of different wave energy converter types, and we've got technologies being developed across the range of power takeoffs. And bear in mind what I said about getting to the end of the Wave Energy Scotland programme, where you've taken the risk out of these technologies and you've got the opportunity to integrate the different subsystems and systems that are being developed to the point where you can have a whole working device. So that is how the Wave Energy Scotland programme is kind of charged with good technologies being developed, aiming towards that integration stage. So just a bit more detail about who's in the Wave Energy Scotland programme. So the power takeoff. A huge number of companies are involved in this, and a huge number of projects. We started off with 27 projects in total being funded by Wave Energy Scotland, and I'll talk to you about how those progress through the stages. But this is just a quick illustration of the great range of companies that are really active in the wave energy sector, developing useful technologies.
And Edinburgh University.
Right, yeah. So, was it the use of the word company that you were... No, companies and academic institutions involved in the WES programme. So couple that with the novel wave energy converter call. This time we have got a series of companies that are developing technologies in collaboration with academic institutions. We've got a really wide range of people from around the UK and Europe, but a lot of really strong Scottish companies involved in the programme. Here's a few pictures of the technologies being developed, and they're in the same places as the logos of those companies. So again, you can kind of see the wide range of different types of technologies that are being tested. And all of these devices here all of these pictures are illustrations of the devices that have been designed and built and tested under the WES programme. And I think all of these, with the exception of this cyber one down here, which was an earlier test, these are all photos of the actual devices that have been funded and tested in Scotland, either at Flowwave here on campus or at the Kelvin Hydrodynamics Laboratory over in Strathclyde University. So a great range of different technologies and a great illustration of really successful early stage development projects of wave energy converters. So as I said, couple that with the number of PTO projects that we've got going and the range of different types of technologies that are being developed there. We've got a real great recipe for combining the two and moving the sector towards that integration stage. So that was power takeoff and novel wave energy converters. Our current call is SMMP, the Structural Materials and Manufacturing Processes. This call has been released over the summer, received a great number of applications from around the world, and is currently going through the assessment process to select which projects will go ahead. So there's no results of what companies are going to be or institutions are going to be going ahead with these projects, but this is the scope of what we've asked for, of what we're hoping to achieve out of the structural materials call. So we did a large amount of research across the sector and across industry to say currently the vast majority of wave energy converters are built out of steel. There are a lot of other promising materials and manufacturing processes which could assist us with reducing levelized cost of energy, which is one of the key targets that we're going for with this process. After having done that research and looked at what are the opportunities exist, we selected the ones that we thought were most promising. So we're looking at the manufacture of the large, in some cases large structures, the main structural body of a wave energy converter. And the manufacturing processes and materials we chose were hybrid structures using rotational moulding of polymers, which is a very low-cost way of making large, potentially hollow, potentially buoyant structures out of polymers. And we were interested in understanding what reinforcement processes are possible in order to make that achievable. Elastomers, illustrated by this boy here. Flexible materials which have that advantage of flexibility, which could be a real benefit in the survivability of a device when it's floating in offshore environment. Concrete, something that's been investigated quite heavily in the wave energy sector before, but just needs a final a study of how applicable it is, how attractive it is finally as a structural material for wave energy converters. And then just to make sure we don't miss anything, the opportunity for applicants to present another material, another manufacturing process that they can illustrate, can provide that step change that we're looking for in levelized cost of energy in wave. So as I said, currently going through the assessment process. Wave Energy Scotland runs a very thorough selection process using external independent assessors to look at all of the applications and score them against a predefined scoring mechanism. So it's a real sort of open, clear and fair process that's utilised to select those projects, and that's currently what we're going through with the Structural Materials Programme. And as I said, once we've completed that, during the next year we'll be moving on to one of the next big challenges in wave energy, which is the control systems, that one of the things that bring all this together. So what does the actual structure of a call look like? Once you've been awarded your project, how do you go through the Wave Energy Scotland process? All of the calls have an aspect of competition to them, and that's linked to that process of pre-commercial procurement. In order for it to qualify as pre-commercial procurement, there has to be some active competition between the projects and between the participants. So that's introduced through using this stage gating process. So participants come in at stage 1 normally, and this varies between the calls, but fundamentally it's all about concept characterization at the early stages, moving on to optimization, engineering development, and the sort of more detailed assessment of the technology, before moving on to potentially small prototype development in stage 3. And at every stage gate in between these, we have a competitive process so that all of the technologies that wish to apply to move into the next stage, and they compete against each other for the next stages of funding. So that kind of brings me on to how we manage that process. Clearly, if you are going to have a competition between different projects, you need to have a competitive selection process. So you need to be able to define what success looks like and what readiness for the next stage looks like. So that's a process that we've been going through all the while, and it's a process that has involved quite a lot of international collaboration, which is what I'm going to move on to talk to you about, which is one of the sort of key activities that we've been busy with. Metrics, the development of those methods for measuring success, has been one of the central things that we've been collaborating internationally on, because it's really important that we can share our approach and hopefully use the same approach as other people, so that everyone's being measured against the same benchmarks. So we held a series of workshops in Edinburgh, Washington and Edinburgh again, with a really wide range of people who are interested in either funding technology development in the wave energy sector, or managing the strategy or the policy that's supporting that sector. And we did that so that we could avoid duplication, make sure everyone's using the same targets if possible, encourage the collaboration, both in this type of approach but also technology development itself, and foster standardization so that everyone's using the same standards. So, developing metrics for measuring success. Why do we need to do that? I said right at the beginning that one of the main objectives of the programme was to get to the point where private investment rebuilds its confidence in the technology that's being developed in this sector. If you can then measure that success in a clear, measurable process, then you can demonstrate directly to them that this technology that's come out of the programme has achieved these measures of success. I'll tell you what those might be shortly. But they can then see that this has been through a process and has been measured and has been shown to be successful. So that's the overall goal, but in the nearer term we need to be able to use those metrics to manage the competitive innovation calls, allocate funding to the right projects, the best value for money, the most likely to achieve technical success. We need to be able to demonstrate that progress back to the people who are funding the programme in the first place, i.e. the Scottish Government, and to the people who we hope will fund technology in the future, those private investors. And it's all about that gaining confidence of investors and stakeholders. And also being able to say, you've come through X programme in the States or in Ireland or in Europe, or you've come through a programme in Scotland, we can all look across those and say, well, that technology has achieved X level in that programme and X level in this programme, and show that we're all trying to achieve the same target, as in the same measure of what success looks like. So, what sort of things are you trying to measure when you're measuring success? All of these are the types of words that funders and future investors and technology developers are looking at when they're trying to say, is this technology a successful technology? So things like manufacturability. Is it possible to easily manufacture it? Has it got the right characteristics when it comes to energy capture from the waves or energy conversion from that kinetic energy into electricity? Is it going to survive? Is it going to survive storm conditions? And overall, most of these feed into this. Is it affordable? Is it an affordable way of creating electricity? And is that something that people are going to invest in the future? So once you've got that what we've called topic area, the thing that we're trying to achieve, you need to have a way of measuring how well you're doing against that, and then you need to decide what's the success threshold, what is the level of achievement in that characteristic that's necessary, either comparing it between projects or comparing it against the overall goal of perhaps levelised cost of energy. So Wave Energy Scotland's always talking about, in the future, needing to achieve a levelised cost of energy of £150 per megawatt hour in order to be able to compete against other forms of clean energy generation. So what success threshold do you need in all of these other things in order to feed into that overall levelised cost of energy that's needed to make a commercially viable industry? So that was a quick run through why we're here, what the programme looks like, who's in the programme, what sort of technologies are being developed in the programme. Alongside that, there's a lot of other ongoing work around knowledge management. That I'll go on to a slide about this in a second, actually, a bit more detail on knowledge management and what we're trying to achieve with that. Industry engagement, technology transfer. There's a lot of technology development across the whole of the rest of the engineering world that could well be of value to this sector. So bringing things into the sector that have already been developed and shown to be cost effective and reliable elsewhere is clearly a lot better than funding redevelopment of subsystems in that regard. Helping to do that across the academic world, we have a link, a joint post with the Energy Technology Partnership, which hopefully everyone will be aware of. It is a pooling organisation for 12 Scottish universities, all involved in low carbon energy research. And that joint post is the role that I fulfilled until recently, and it's a role that will be advertised shortly for a new joint Wave Energy Scotland Energy Technology Partnership person. Funded research, all of these research and development activities. And I'm going to go on to the next slide, which just talks a bit about what knowledge management activities we're doing. So a huge body of knowledge is available to Wave Energy Scotland and to the sector, either from activities that are happening around the sector, landscaping projects that we've carried out, an example of that being the project we did about structural materials, trying to find what are the opportunities for different materials. Knowledge capture, gathering all of that knowledge that's been developed in Scotland by various companies over the last few decades and making sure that's kept safe and made available and made useful to other people who can use it. Out of all of the technology development projects, we've got reports that are created as deliverables. Those are coming into the body of knowledge. There's IP and data that's being developed, and there's also academic research that's being carried out, for example, the 2ID core projects. So a huge body of knowledge is being created that's of extreme value to the sector. And we want to create a knowledge management approach to make sure that we can manage that huge body of data and make it available to the right people in support of the sector. So sharing that with WES Programme participants where applicable, and then public dissemination, collaboration, IP licensing of that, all that information to help people across the sector not redevelop the same technologies and the same solutions. So that was my very quick whistle-stop tour through what Wave Energy Scotland is, what the objectives of it, and hopefully that's fairly clear that the objectives of Wave Energy Scotland are to develop technology to the point where private investors have the confidence that this technology is reliable, is affordable, and is suitable for commercialisation. We're doing that through a innovation and technology development, research and development programme. We've got power takeoff, novel wave energy converter, structural materials, and in the future controls calls happening. There's a great selection of technologies, of companies and academic institutions, both Scottish and worldwide, involved in the programme, developing a really wide range of technologies that are pointing us in the right direction of that recipe of integrating technologies in the future. There's a very structured approach to managing those competitive calls and managing the technology developed in them. And we've got really strong links with international collaborators who are trying to do similar things in different countries to make sure that when we measure success and when we share information, it's done in a way that's consistent across all those different countries. So hopefully that's given the people who've not heard of Wave Energy Scotland before a good understanding of what we're here for and what we're trying to do, and hopefully been reasonably interesting for people who have known about Wave Energy Scotland for a long time. And once again, thanks very much for the invite to come and speak to you.
This production is brought to you by the University of Edinburgh.